Good afternoon. Hello again. Welcome, everybody. Thanks for joining us for today's webinar, ADMS, an integrated platform for enhanced operations, outage management, and delivery optimization. Presenting today's webinar is Rob Sadler. He's our Director of Business Solutions. As part of the sales and marketing team, he oversees technical pre-sales and product marketing. He also performs product training and demos, serves as a technical resource for the sales team, and supports key RFP responses. He received his BSEE from Georgia Tech with a certificate in computer engineering. Prior to MNSite ACS, he was a project engineer with Siemens in circuit protection and controls. Assisting Rob today is John Groders, Business Development Director for Grid Innovation. Just a few housekeeping items before we dive in. There could be some technical challenges, especially with the increase of Zoom users and everybody working from home, so just bear with us if that happens. This webinar is being recorded, so we do have everybody on mute and the chat is disabled. We do encourage you to ask questions at any time, though, during this presentation. So if you have any questions, just use the Q&A button at the bottom of your screen, and we'll get to those at the end. And that's all I've got. Rob, if you're ready, I can turn it over to you.
All right. Thanks very much, Delana. I appreciate that. And on behalf of MNSite ACS, I'd also like to thank everyone for taking the time out of your busy schedules to join us for the webinar today. We know working through the conditions in a pandemic like we are today presents some challenges, and we appreciate your time. We know it's valuable, and thanks for joining. We hope you find something valuable to take away from today's presentation. So we'll jump right into it. So the agenda that I'll work through today, we'll talk a little bit about the background of ADMS, Advanced Distribution Management Systems, look at some of the trends that are driving the adoption of these systems today, and talk about some of the traditional approaches to the components of an ADMS and how different vendors and different customers have approached the building and deployment of an ADMS from different directions. Discuss how ADMS is defined today, kind of in the industry in general, and the MNSite ACS perspective on that. Talk a little bit about the structure of our product for advanced distribution management. It's our Prism ADMS platform. Dive a little bit into some of the, not all of the ADMS functionalities, but some of the key core ADMS functionalities and their benefits that bring value to the utility. Talk briefly about where ADMS is headed, the future of advanced distribution management systems, and then we'll jump into Q&A, where, as Delana mentioned, I'll be joined by John Groders for that portion of the presentation. So again, we encourage you to ask questions as we move through the presentation today by using the Q&A feature in the Zoom panel. So let's go ahead and jump right into it. Before I get into the first item on the agenda, I wanted to spend just a few minutes for those of you who may not be as familiar as some with MNSite ACS and MNSite and parent company Indra. Spend just a few minutes here at the outset giving you a little bit of history of our company and our parent company, MNSite ACS. Otherwise previously known as Advanced Control Systems, since our inception in 1975. Of course, we've been around the industry now for 45 years, originally starting out as an RTU manufacturer, and over those 45 years, as you can see on the timeline there, we've got a legacy that we're really proud of in terms of the developments we've introduced to the industry and some of the things we've been involved in at the outset of new technologies, whether it be early distribution management system, Unix EMS applications, playing a key role in the development of the DNP3 over IP standard, to deploying really the first fully automated distribution management system with Flizzer back around 2000. And of course, you can see moving on through the years, through the advent of feeder automation platforms, some of our mobile applications, advancement of our full ADMS suite, and then you can see in 2018 the acquisition by Advanced Control Systems of Indra. So we have over 250 systems deployed worldwide today. You can see 22,000 RTUs delivered throughout our history. And this year, actually, I think would have been our 42nd annual conference if it hadn't been scuttled, unfortunately, by COVID-19. But we do look forward to a virtual conference for our customers coming up here towards the end of the year. So we're based in Atlanta, Georgia. And a little bit about our parent company. We're known as MNSite ACS. MNSite is one of two business lines in the Indra family. Indra is a large global consulting technology product company headquartered in Madrid, Spain. You can see some of the key figures there in terms of $3.4 billion in sales. 49,000 plus employees around the globe. And you can see the two different business lines that make up the Indra family. The Indra name these days consists of our traffic and transportation and defense solutions, whereas MNSite is the information technology digital technology arm that serves different verticals such as energy and industry, financial services, telecom, and health. And of course, MNSite ACS, as you can see there, obviously fits within the energy and industry vertical of MNSite. This kind of gives you just a bird's eye view of solutions in the MNSite portfolio in the utility space. And that starts with some of the traditional OT solutions that have been offered by ACS throughout our history, including SCADA, distribution management, outage management, RTUs, feeder, substation automation, some of which we'll be talking about today. But as you can see, the MNSite portfolio spans everything from generation down to the customer, from plants and energy management, grid management, DER, prosumer, smart metering, as well as customer management applications. And those are all supported by some complementary solutions that include the IGEA GIS solution, energy trading risk management. We have a cybersecurity services organization. So it's a pretty broad portfolio of solutions that serve pretty much all facets of the energy industry around the world. So with that out of the way, we'll go ahead and jump into the meat of today's presentation. So before we get into the specifics of advanced distribution management systems, why is an ADMS important today, and why are utilities moving towards this integrated platform for distribution management? So a changing grid, means a necessary evolution of control systems in today's landscape. So operations are being challenged, of course, as the grid evolves. We have it's less forecastable, less dispatchable, or we lose some visibility through mask load from DERs. We have more sensors, a flood of data that's coming on to the system today from the proliferation of sensors that are on the network, and the amount of data available today to today's operator, and the challenge is finding some way to turn that data into information that's useful to the utility. And then of course we're all familiar these days with the impact that increased penetration of distributed energy resources are having on the distribution grid in terms of the dynamics of the grid, two-way power flows, and trying to adapt a power system and control systems that were not designed to effectively manage that type of grid. So some specific drivers, those are some of the changing aspects of the grid in general, some specific drivers that those produce that are moving us towards this integrated ADMS world. Our resilience and increased focus on the ability of the grid to withstand and recover from natural disasters. Of course, we've hurricanes and other natural disasters have been more prevalent in the news in recent years, and the devastating impacts they can have on the grid. And so utilities, of course, are rightly focused on ways to ensure that the grid can be more resilient in the face of those types of events, and keep power on to as many of their customers as possible, and enable more rapid restoration. Renewables, we've mentioned, the ability to accommodate larger quantities of those to take advantage of those and mitigate any negative impact on power quality. Replacement of aging technology. So many utilities are facing the obsolescence of legacy systems that have been in place for many years, and face the daunting challenge of trying to coordinate replacement of multiple systems, trying to determine whether some of those should be consolidated, and of course trying to work together between departments and groups within the utility to make sure they make the best decision for their utility that provides the greatest return on investment. Of course, regulatory changes drive many of these decisions around reliability and efficiency, depending on what market a specific utility might be operating in. Safety, of course, is not something new. That's always top of mind for utilities, but as we add additional automation and switching capability in some of these advanced applications to the grid, safety has to remain paramount, and we have to ensure that the systems that we're adding take that into account and don't introduce any potential additional safety issues for utility personnel and the public. And then, of course, there's asset utilization, and that's leveraging a lot of the capital that's already been invested by utilities over the years, whether it be in expensive AMI solutions, communication networks, and some automation outside the substation fence, and taking action and deploying applications and systems that can help improve the life of assets on the system, such as transformers, capacitors, reducing the amount of load tap changer operations, breakers, recloses, switches, and leveraging the equipment that's already been installed without having to make additional investments to support new technology. Well, you also, and also at the bottom of this slide, of course, from our friends at Newton Evans in a recent survey of the landscape for DMS, OMS, and EMS technologies. Again, some of the applications and some of these we'll be talking about today that utilities are considering using to help address some of these issues that we've talked about. You can see the number of them that are either already using or have a plan to use with regard to visibility, FLISR, network optimization, integrating DERs, optimal feeder configuration, protection coordination, and those are some of the applications that we'll be talking about. Looking at it another way, some of the technology trends, again, these are all interrelated, but we talked about replacing legacy equipment and looking at system consolidation. So as those systems are replaced, looking at what makes sense to deploy on a common platform. And then we've talked about it a lot over the years, but it is something that needs to be mentioned, and that's the convergence and growing together of IT and OT within the utility, the blurring of that line. With regard to systems that monitor and control the grid and track and restore outages and communicate with the utility customer. Of course, the evolution of the enterprise and interoperability between systems requires greater levels of integration between these technologies, and the increased importance of providing critical information and having it at the ready to crews and personnel that are in the field, i.e. mobility, is also something that's ever growing in importance. Analytics and big data, we mentioned the number of sensors and additional information that's available from the grid these days. That requires new technology, not only to be able to ingest and store that data, but more so to make sense of it, to analyze it, to process it, and allow utilities to use it in a way that adds value. Energy efficiency and demand response, of course, are always important, and another area that is driving the integration of these technologies. And then, of course, there's always as we've mentioned a couple of times already, the need to effectively manage distributed energy resources connected to the distribution grid. So how is an ADMS defined today? We'll talk a little bit about how we see it in a moment, but you'll get varying definitions depending on where you look throughout the industry. And I think both of these definitions that you see here are fairly similar and cover most of what we would look to see an ADMS provide. The top one, of course, is from the Gartner IT Glossary. An advanced distribution management system is the platform that supports a full suite of distribution management and optimization. It includes functions that automate outage restoration and optimize performance of the distribution grid. ADMS functions being developed for electric utilities include fault location, isolation, restoration, volt VAR, reactive optimization, conservation through voltage reduction, peak demand management, and support for microgrids and electric vehicles. So that's more of a functional description. The Department of Energy's definition is fairly similar. But let's talk a little bit about the evolution of legacy systems to ADMS and the way we at MNSite ACS and many of our brethren look at advanced distribution management systems. So in the traditional world, you've got the IT and OT domains, operational technology and IT within the utility. OT typically managing the real-time control systems, so SCADA in the control center, real-time RTUs, IEDs, communications in the field, and of course SCADA being a core and critical system for utilities to manage telemetry, data on the system, control devices remotely, alarming, tagging, and trending. Whereas the OMS typically was a domain of the IT department with call takers handling trouble calls on the system with a topology model to handle outage prediction, calculating restoration times, notifying customers, and of course tracking outages through restoration, managing the crews and work needed to do that, and providing switching in order to effectively restore from outages. And then of course advanced DMS applications have been around based on load flow, load estimation and state estimation of the distribution network in order to provide analysis and automation and optimization applications at the distribution level. DMS has always relied on the SCADA telemetry, which is critical to operation of those applications. And so DMS and SCADA have always been closely linked, if not delivered on the same platform. And of course, what you don't see here is often there's a link between SCADA and OMS as well to provide switch and breaker status to the outage management system. So kind of the first evolution towards what we see today's ADMS was really considered just the combination of SCADA and DMS on a real-time platform. So a common platform with both a real-time database and a network model that shared the database as well as a common user interface. So it provided some integrated control and analysis as well as a common user interface and enhanced visualization tools for the operator. And typically there was still a link there to provide for switching and to provide breaker status to the OMS. And then as we move towards what we look at as today's advanced distribution management system, those systems combined under a combined IT-OT environment to create what we see as today's modern advanced distribution management system, where the ability to optimize and analyze the system, to control it, to track and restore outages, and to optimize it, all of those features are integrated together with a common model, a common database, a common user interface to help provide even better situational awareness and efficiency to utility operations. So what are some of the platform requirements for today's ADMS? Performance, high availability, I think are fairly obvious. It's a mission critical system. So parallel processing capability, high-speed data buses for integration among the systems that provide data to the ADMS. High availability as far as no single point of failure. the ability to provide multiple failover levels, and systems need to be scalable both horizontally and vertically to be able to serve growing utilities and potentially to be able to serve utilities that may be looking at a phased implementation rather than a big bang deployment. So they might be looking to deploy only outage management system with SCADA and then add DMS to that platform at a later date. Integration, of course, using standards-based interfaces, whether that be the Common Information Model, multi-speak web services, OPC, to share data between the ADMS and systems that it both feeds and requires data from. Flexibility in terms of the architecture with multi-site, disaster recovery, the ability to support multiple regions within a utility, and the multi-phased implementations that I mentioned. Visualization capabilities are key with respect to providing operators with the different views of the network that they need, whether they be geospatial or schematic, or a combination of which that we'll talk about momentarily. And then, of course, different environments for production and non-production so that we can effectively support the maintenance of the model for the database and model changes on the development system, fully testing those before they get promoted to production. And then, of course, QA environments to facilitate testing and patching and to ensure that the system is always up to date. And then training environments for dispatcher training and simulation. Today's ADMS requires multiple types of clients, of course, not only control room clients for the operator, but increasingly remote and web clients, read-only clients for personnel in the field to view the system in real time using mobile devices. And of course, last but certainly not least is security, adopting SIP standards as best practices even at the distribution level, and providing for remote access, data replication, and supporting Active Directory within the utility. So the core of the ADMS is the network model. It's really the heart and the soul of the system that enables all of the advanced applications that utilities rely on the ADMS for. So it's an essential element of the system, and the distribution system model is fed with information from multiple sources, and of course then is a source of information for not only the operator displays, for the power flow, which feeds the advanced applications, and also the topology that's used to manage and track outages. The distribution system model is typically fed from a single source of truth, which is the geospatial or the GIS, the Geospatial Information System. And that's where we get the attributes as far as wire sizes and device ratings, coordinates, land-based information that's supported as well, feeding that distribution system model, as well as potentially power system information that might come from a planning model as well, to build not only the underlying network model, but also the load model and load profiles that are used by the load estimation and state estimation applications. And of course, the live data and telemetry from SCADA is the other critical part, of course, in performing accurate power flows and load estimation in order to feed the advanced applications. So network model maintenance then, obviously, if the model is that critical, then the ability to maintain that model is equally as critical. So model maintenance tools should support incremental updates so that the entire model doesn't have to be re-imported and converted each time changes are made to the utility network. In the case of the PRISM model importation tool that we call DASMAP, it supports interoperability with pretty much every major GIS platform that's on the market. And ideally, you want to be able to support automatic reduction to a three-phase backbone and the ability to provide geoschematic displays from that import process, perform error checking and tracing, and theming and conversion functionalities as part of that import process to make sure that the map and the model that are imported to the DMS is as accurate as possible and represents the network in the way that that operators expect to see it. So with regard to the platform that MNSite ACS offers to the industry, this is a snapshot of some of the traditional applications that are part of our portfolio. And of course, what we're talking about today really resides within that red box there, our core SCADA platform upon which we build the advanced applications that can be deployed modularly for outage management, for distribution management, integration of DER, and then of course combining all of those functionalities for an integrated ADMS. So our ADMS, as we've mentioned already, is a common platform for distribution management, SCADA, outage management on a real-time database with a real-time model that provides, as I've mentioned, both a modular and flexible platform so that utilities can start with SCADA and then add in a modular fashion either distribution and or outage management on top of that real-time platform as their schedule and resources allow them to do. So the applications that, again, these are core applications that should be a part of any modern ADMS. These are the applications that MNSite ACS offers as part of our PRISM platform. We break these down into a number of different functional areas, beginning with analysis, and of course the core applications that enable the other advanced features start with the distribution power flow. It's a three-phase unbalanced power flow, load estimation, and of course distribution state estimation. And then once those applications have been deployed, the model has been created, then the other analysis applications that you see here can be added. And so as the term analysis implies, these don't perform real-time changes to the system. They're used by dispatchers to perform analysis on the current state of the network, whether that be short circuit analysis to locate faults, determine optimal capacitor placement. We'll talk about optimal intelligent switching in a moment. Protection coordination permits the evaluation and coordination of curves on protected devices on the circuit. And then of course, real-time study mode permits operators to have individual study modes that they can use to evaluate actions on the system without actually performing those in the field. Visualization tools include Topology Processor, which provide the colorization and connectivity that you see in this image here, so that the display can be colored by outage, it can be colored by loops, and it can be colored by voltage, it can be colored to indicate load violations. So there are a number of visualization options that are provided with Topology Processor. We'll talk about Reshape Schematic Generator here in just a moment. And then Grid View is a Google Maps enabled tool for looking at system status in real time overlaid on Google Maps. So automation and switching, really probably the most common applications that utilities initially are building the business case for as far as ADMS deployment, and that's what we call FLISR, or here indicated as fault detection, isolation, and restoration. Those are really two terms for the same application, FLISR being fault location, isolation, and service restoration. So that's a self-healing feeder in response to faults on the network, and then of course integrated volt-var control for optimizing and improving power quality. And then switch plan is a tool for generating switching orders on the system to replace the paper switching process, and it's also used by the other advanced applications to automatically generate switching plans according to objectives that are defined by the operator. And then, of course, the outage management capabilities, including call management, call taking, prediction analysis engine, crew and work management, restoration switching, again, which utilizes the switch plan application, and then the public outage map. We also offer a full dispatcher training simulator that uses both the control center and power system model to permit training of dispatchers from saved cases, can also be used for operational planning purposes. And then, of course, mobility, as we mentioned, is another key aspect of today's ADMS. So we offer tools for, as you see in the image to the right, not only visualization of the network status and devices in real time on Google Maps, but also the ability through our Power Mobile application for crews to view real-time work orders, switching steps, and outage work assigned to them in the field related to both outages and service orders on the system. So we'll talk a little bit about some of these applications and the benefits they bring to the utility. We won't cover all of them, but some of the key ones that come to mind initially with ADMS deployment is visualization and improved situational awareness for operators. So the traditional, there's still some control centers out there that look like this. They're becoming fewer and fewer, but the traditional map boards, push pins, post-it notes to represent the status of the network, and of course those are rapidly being replaced with digital displays, either just at the dispatcher desktop or large control room displays like this that allow a full geoschematic view of the entire system network that of course operators can drill down into to view a geospatial view or to view schematics and one lines of individual substations and circuits. So as we continue to automate outside the substation fence and be able to visualize what's going on outside the substation on the feeder all the way down to the customer meter, this type of dynamic display and visualization becomes more and more important. So there are a number of things in ADMS we can do to take advantage of these technologies, and one of those is geoschematic display generation. So of course the display and the map that's integrated and imported from the GIS is geospatial, of course, like you see in the image on the left. And of course that map is then imported and digitized and converted into a dynamic colorized DMS display like you see here, but also through our mapping and conversion tool, we have the ability to automatically through that process create a reduced version of that network that operators might prefer to use for switching, and we can reduce that complex network down to the three-phase backbone, and then we can make manual adjustments to that. We can exclude certain objects from view. We can stretch some circuits and manipulate them, as you see has been done in these images here in the top right. We can orthogonalize and put branches at right angles to give us more of a geoschematic view that's more friendly in terms of operators using for switching. So we have the ability to automatically create these displays as part of the map import process, and here's just another example of that. Being able to automatically convert a geospatial view like this into a geoschematic view like you see here and in this example here, again, without having to create those displays separately or by hand using a different editor. So these are tools that greatly enhance the operator's ability to use the system effectively. And then we also have another tool that's dynamic schematic generation. And so even after the import process and the map is built, the operator at any time can simply select a circuit in the map view and dynamically generate an operable schematic of that circuit from the source to the load, and use that for switching purposes, again, without having to build that in an editor. So beyond visualization, another key reason that utilities adopt ADMS is to provide intelligent and optimal switching. Some might also refer to part of that as optimal feeder reconfiguration. So the operator now has a greater ability to automatically generate switch orders and switch plans in response to real-time conditions on the network, and view those switch plans and digitize them right within the operator interface. And so that can include tools that allow operators to build switching requests ad hoc directly from the system display, and then have those requests go through a standard approval process and scheduling process before they are executed and archived. So we can completely replace the traditional paper switching process. And of course, that same application is used by the intelligent and optimal switching applications within Prism. Intelligent switching providing the ability to generate plans for return to normal following restoration from a fault, to isolate devices, to restore from outages, cold start switch plans. And then optimal switching allows the operator to generate plans to meet operational objectives on the system, whether that be minimizing power losses on a section of the network, voltage drops, or balancing load. And so all of those applications are generated in the switch plan tool. and then the operator and approvers have the ability to review those, approve them, change them, and execute them either manually or automatically through the switch plan application. Flizzer is, as I mentioned before, is an important and one of the more important applications that's deployed today on ADMS. We first deployed Flizzer successfully for Taiwan Power Company back in 1999. System went live in 2000. So I won't go into detail here about the operation of Flizzer, but of course it's essentially a self-healing application to automatically reconfigure the grid remotely and automatically in response to faults on the system using the network power flow and state estimation to isolate the circuit, restore power upstream, and then of course look for the appropriate solution to restore customers downstream of the faulted section, which of course provides a number of benefits that utilities use to help build a business case for ADMS, improving reliability on the system according to the metrics that are normally used to evaluate that: customer minutes of interruption, SAIDI, CAIDI, improving customer satisfaction as a result of that reliability improvement, and of course making the workforce more efficient, reducing unserved energy due to smaller outages and shorter duration outages, and of course also helping to reduce the outage cost to the utility customer. So at the bottom you see a typical timeline for a manual fault restoration without automation, where the fault might take in excess of an hour to locate, isolate, and then provide partial restoration in response to a fault. Whereas with Flizzer deployed on the system, that isolation and partial restoration can be complete in a minute or less. And of course, the key there being, as long as we keep that under 5 minutes, we've kept that particular outage from being a sustained outage that's reported in our performance indices. So Flizzer can have a significant impact, particularly on more problematic areas of the utility network. And then secondary to Flizzer probably is integrated volt VAR control. Some might refer to it as volt VAR optimization. But again, improving the efficiency through voltage optimization on the network, reducing the demand and or energy, depending on the objectives of the utility. And of course, used in concert with Flizzer, can continue to optimize the grid in combination with Flizzer, even when the network is in an abnormal state, whether that be as a result of a fault restoration or seasonal switching. And then, of course, IVVC can also be helpful in helping to enable the widespread deployment of DER on the distribution network by helping to manage in an integrated fashion any voltage issues which might be presented as a result of that deployment. So moving on to one of the last specific benefits and solution areas that we'll talk about is DER integration. So we're not talking about necessarily a full-scale, full-board DERMS solution, but a DER-aware ADMS that uses the DMS applications such as optimal switching, IVVC, Flizzer, and some others developed specifically for DER, such as feeder injection testing and maximum injection forecast, particularly for PV, using those on the ADMS to help optimize and control DER that are pretty much limited to utility scale. So the ones that are utility scale on the network that could have a major impact on the operation of the grid and power quality. So we have applications that we've built into our DMS that allow utilities to use them to optimize those resources and to manage them effectively at the utility level. And just as an example, we have functions that we refer to as emergency load transfer, injection capability, feeder injection forecast that are all used to help maximize the penetration or maximize the injection of PV on the network without having to curtail. So we use integrated volt VAR control along with load transfer and switching to help mitigate any voltage issues, temporarily transfer load to manage voltage, and ensure that any PV on the network can be used without curtailment. Simply one example of the solutions that we have available. An example of this in use is a pilot study that we participated in as part of the EPIC project in California that took place in conjunction with Quanta and SDG&E. And in this particular scenario, our DMS with IVVC was utilized on some models of some pilot circuits to evaluate the effectiveness of IVVC with renewable DERs modeled in the network to manage the feeder in response to different scenarios. In this particular case, a large DER was tripped offline, and you can see that the two different scenarios here, the one on the left without IVVC, the one on the right with ADMS and IVVC from MNSite ACS, which you can see was able to flatten the voltage profile better and respond much faster than a system that only used localized control on the same circuit with the same conditions. And I won't go through the table, but you could see some of the improvement metrics that were realized on the test circuits as part of that particular pilot project and study. So kind of summarize here at the end before we get into Q&A with some benefits of an integrated ADMS. We've talked about some of these, but some of the core benefits, of course, are deploying a system that uses a single model and common graphics and common maintenance. So that greatly reduces the management and maintenance effort by utility personnel to maintain the system. So multiple copies of a model and database do not have to be kept in sync manually. So all applications are supported by the same high performance real-time database as well as data model. Operators have one common graphical interface to utilize, so they don't have to learn to manage multiple systems and have multiple solutions on their displays simultaneously. Safety, of course, being able to effectively manage tags, to know that data is accurate without having to wonder about the effectiveness and performance of links, data links between systems. And then, of course, some of the visualization aspects we talked about with regard to geoschematic and schematic generation. Real-time redlining, so that's the support for temporary changes by operators on the system to the as-operated model, so that the applications that we're running, in addition to the outage prediction analysis, are always being performed based on an actual real-time representation of the connectivity of the network if temporary changes are made in the field. Of course, real-time outage tracking and restoration. So we've got integrated visualization with SCADA DMS when switching and crew work management, and automatic ticket generation and restoration when SCADA devices are responsible for outages, as an example, in response to a fault. Advanced network analysis applications. We've gone through some of those, but real-time archiving, we didn't talk about historians, but historian and effective data archiving and historical data analysis is another important aspect of an ADMS. And we support, of course, a full temporal data model that defines object-oriented relationships, hierarchical relationships of the data that allow utilities to easily create ad hoc reports, build dashboards, and distribute critical information in rapid fashion to other personnel within the utility that need that data. We talked about a common point of maintenance, scalability and modularity, so that systems can be deployed in a flexible fashion depending on the utility's needs. And lastly, specifically in terms of benefits to the MNSite ACS ADMS, we feel is our experience. Whereas there are some vendors in the space who only recently have had successful deployments of FLISR go live. We deployed our first solution with large-scale FLISR back in 1999, and our first ADMS that included outage management in 2007. And to date, we have thousands of circuits that are actually automated and live with FLISR. So our experience there, we think, is second to none in the industry. And before we go to Q&A, the last thing is, so where's ADMS headed? Some of these things that we're already working through today and integrating into our technology, but some of the things at kind of the leading edge of ADMS systems are, the integration of grid edge information directly through industrial Internet of Things and distributed data service. So using DDS and particularly in our case, the iSpeed solution from MNSite to take grid edge components and data from grid edge directly, and use those where they need to be used in other systems without necessarily having to go into the core real-time database. So we make that data available through publish subscribe methods to the services that need it, supporting multiple protocols and messaging services. Application containerization and microservices is something that we're also very involved in these days. We have a solution called the Node 1, which is an IIoT grid edge module that already incorporates components of containerization. And we've developed much of that capability through our close partnership with Intel, which we're quite proud of, and that will continue to be a important aspect of effective management of grid edge devices and incorporation into ADMS as we move forward. Real-time analytics and data science and some of the more deep data analysis and things like image recognition are things that we're also working on, and we have the capability of doing some of those things today through our MNSite grid and operational intelligence platforms. And those capabilities are being rapidly integrated into our core ADMS platform. And of course, the industry continues to look at and take advantage of artificial intelligence and machine learning applications to effectively manage the grid. And that's something that our software teams in Spain are actively working on as well. So we're excited about the future of ADMS in general and where our solutions are headed, and the types of things that we can do for the industry. So with that, John Groders will join me, and we'll start taking a look at some of the questions that we have. John, you want to go ahead and take a look at those, and we'll see if we can get them all answered in the time that we have.
Yep, absolutely. Thanks, Rob. Looks like several have come in already, so we will do our best. If we don't get to any of your questions, we will certainly, we have your information, we'll answer them offline. But just quickly, if you do have any specific questions or want to see, a demo or an implementation of any of these solutions that Rob discussed, feel free to contact any of the sales directors. All their contact information is on that slide there. So let's jump right into it. So the first one, on the topic of replacement of a legacy DMS, what would you say a normal project timeline is for a phased ADMS delivery for your platform? So typical project delivery, I'd say, for an ADMS.
Yeah, so our phased ADMS delivery, so it really kind of depends on the phases, and obviously depends somewhat on the size of the utility, of course, right? Because an ADMS maybe for a 100,000 meter utility is going to be a slightly different project than one, say, for a 5 million meter utility, simply due to the sizes of the models and the databases and complexity. But I'd say, to give kind of a general answer to that, most of these systems can be delivered, say in probably 9 to 12 months, for a kind of a tier 2 size ADMS solution. And again, that's going to vary also in terms of the phasing. So are we delivering a full comprehensive ADMS with both DMS and outage management, or are we only delivering outage management first, which only requires topology and building a network model as a second phase? So lots of variables go into that equation, but probably say 9 months on the low end is and to go live is probably a best case scenario.
Okay, and I'd say certainly a lot is dependent on what the integrity is of the existing GIS model, how much work needs to be done to get that cleaned up to use it as a real-time model.
Exactly, because that is often one of the biggest challenges in deploying, for not replacing another system or one where a model has not been utilized for advanced applications and power flow. That often is one of the more significant challenges to a successful deployment is getting the data correct at the outset of the project.
Okay, great. Next one, obviously, it's certainly somebody that's familiar with our specific products. They said, have you guys incorporated iSpeed into your ADMS? And you actually touched on that at the future of the ADMS, but if you just kind of wanted to, it has been already implemented and we certainly are going to use that as a real-time integration platform moving forward.
Absolutely, yeah. So one of the early integrations really following our joining with MNSite was the integration of iSpeed into our Prism platform, so that we have an integration method directly into the iSpeed bus. So we've already done that. That capability is already part of our portfolio. Yep.
Okay, great. So next one I can help address. It says, can the platform help develop hosting capacity? So when they say develop it, it's not necessarily a planning tool. So I don't know if that's what they're looking at, but this platform certainly, and for those that may not be as familiar with the term hosting capacity, it's basically how much DER penetration, how much rooftop PV, how much generation can a particular feeder or part of the system take before basically there additional, whether it would be reconductoring or additional infrastructure changes would be needed. So certainly an ADMS with the incorporation of volt var optimization and some of these advanced applications can absolutely increase hosting capacity just simply by alleviating some additional voltage issues that could be seen when DER penetration happens. Also, it could alleviate potential reverse power in areas that the system can't normally address. So certainly an ADMS and incorporation of DER and other sensors can definitely increase hosting capacity. I don't know if Rob, if you wanted to add anything to that.
No, I think you handled it perfectly. Yeah, I don't know that I can add much to that. I think that's a good answer.
Next one, I think we can do our best try to answer, but it's really a tough one. So this all assumes heavy device sensors, control, instrumentation on the grid. What is the business ROI for overall CapEx spend and break-even point time frame? I'd say the best answer on that is it depends.
Yeah.
But certain, I mean, I would not, and maybe some utilities have some better technical white papers that may address what they've found. But the one thing I will say is sensors are becoming more economical. All of these IEDs have so much more processing capability out on the grid than ever before. Communications infrastructure is decreasing. So all of this is leading to just simply more data, more visualization outside of the substation fence. And the next step is really just how do we handle all that and what is the best way to handle it? So Rob, if you want to add.
Yeah, I mean, you're right. That's a great question, but it's also a really tough one to answer because, like you said, it depends, and that's that's something that utilities have traditionally and continue to struggle with in terms of developing a solid ROI and business case for certain, softer aspects of ADMS, but it really, there's so much that goes into that, depending on the regulatory environment that the utility is operating in, what regulatory pressures they have, what mandates. There are lots of things to consider there. So it's just there's not really a one size fits all answer to that, unfortunately.
Okay, great. What tools do you use to develop optimized asset location, for example, cap banks? Well, specifically for cap banks, we actually have a module as part of our ADMS package that you can look for optimized locations for cap banks where you do need specific VAR voltage support. If you want to add to that, Rob.
Optimized asset location. Yeah. So I mean, that's our optimal capacitor bank, application really is the primary tool there. Of course, we do have the simulator that can be used for some operational planning tools. So outside of the traditional planning environment, the DTS can be used with save cases from real-time operational conditions, or specific conditions can be built in terms of a scenario to help kind of run what if scenarios on the system in order to help determine the best utilization and placement of other assets specifically. So that's probably the best way to utilize the system for that.
Okay, good deal. Another one about DER and DRMS. Should DRMS be integrated with ADMS or as a separate system? What about DRMS, or a demand response management system? I'd say that question is very specific to the use case that the particular utility is looking to achieve. If the use case is utilizing that DER asset for a grid service, so to alleviate some potential high demand, or alleviate a congestion on a certain feeder, or assist with voltage support, in that regard, yeah, you definitely would want to look at having that DER as an extension of your DMS capabilities. If you do get into more of the demand response management system, traditionally, those have been very siloed and separate from the real-time system operation. However, there's certainly definitely a trend happening where utilities are looking for that integration path where they can leverage the system model and system operation, and also use that in conjunction with their demand response or their load flexibility capabilities. So there's a definite convergence of those two worlds that we are seeing, and certainly going back to that's where some of our real-time system integration capabilities can really come into play, where we can kind of bring all of those different use cases together. Let's see here. I don't think we're going to be able to get to all of these because we've got quite a few coming in.
Yeah, we have some really good questions, and since we're running up close to our time here, and we don't want to keep you over, well, questions that we're not able to answer here, we'll certainly address. We can address with you via email. So we'll do our best to get to all of your questions answered.
One last one. It's a good question, and very much hits on a key point of where the industry is going. Is what are your thoughts on smart control at the edge using intelligent devices rather than centralized ADMS doing command and control by taking all the data to SCADA and ADMS? And I will just kind of end it on this one, but that's very much what Rob was discussing as kind of where is ADMS going and where do we see it going? We do see that it is going to be a hybrid approach where not everything from the grid edge is going to be able, it's just not feasible to bring all that data back and process. So to reduce latency, to reduce bandwidth, there will need to be some intelligence at the grid edge. And that's certainly where we see it, and that's where we're headed with ours. ADMS is still going to be a very necessary centralized system, but it will need to allow for some intelligence at the grid edge to take care of some more, have some faster, quicker decisions. So it will probably be moving more towards that hybrid structure. And I think
Yeah,
with
no,
that, go ahead, Rob.
No, I was gonna say that's a perfect answer, and that's why the IoT and grid edge components of our solution, will become more and more important, because the future really is a hybrid solution. As the grid becomes more distributed and multi-directional, we're going to have the ability to respond more rapidly in certain conditions at the edge. But obviously we'll still need the centralized, and holistic view, of the grid in order to make the right decisions about how to operate it from that level. So a hybrid approach is certainly where we're headed. Yep.
Okay, well, there are some that we didn't get to. We will certainly get some answers to those. But with that, I'll turn it back over to Delana to close us off.
All right, thanks, John. Thanks, Rob. I just want to thank everybody for joining us again today. And I do want to remind you, we've got one more webinar coming up on August 19th. It's also going to be at 3:30 Eastern Time on a pretty hot topic. It's Rise of the Prosumer. And you can find information to register for that on our events page of our website at acspower.com. And then we'll be announcing some more webinars coming up here soon, so just be on the lookout for those. Thanks again for joining us today. Bye, everybody.